We're on page 11. Yes, right there, page 11. All right, so we started talking about this yesterday. We did or say Tuesday or whatever day it was.
Yeah, you didn't tell us.
We did a lot about yesterday. Yeah, yesterday we had testing. Didn't happen. Which?
I didn't know.
So here we go. We're dealing with fourth root. So like letter C. Basically, what we did is divided it by perfect fourths. I guess is the word for it. So if you don't have a calculator, find one. But here we go. Let's start dividing it by fourths. 80 divided by 4 to the fourth. 3 to the fourth. 2 to the fourth. And you find that 2 to the fourth times what will get you 80?
2.
Bigger than that.
4.
2 to the fourth times 4?
Oh, no.
80 divided by 2 to the fourth would be 5. Cool? So then I can confidently say, well, then the fourth root of 80 is also the fourth root of 2 to the fourth times 5. Which means I can finally reduce that by saying, hey, which number comes out, the 2 or the 5? The 2! And the 5 stays behind because the 2 has a fourth on it, so those can cancel each other out, but not for the 5. Okay? The 2's got the magic wand of the fourth. Yeah, whatever. All right, so that's your final reduced answer. Cool. Letter D gets a little bit crazier, but that's okay. We'll talk about, we got to rationalize that denominator, and we did this the other day, but we're doing it again. So I will be sure to confuse the mess out of you. All right, so to cancel out this on bottom, I need 4 to the fourth in the denominator, okay? I only have 1 there so far. How many more do I need? 3. So, fourth root of 4 to the third. Okay? And whatever you do on bottom, you do to the top. Now, I'm going to come back and deal with the top in a minute. But I want to finish up, that way I'm not starting like, let's think of how to do the bottom, then how to do the top, then back down to do the bottom, and you're not re-gearing yourself constantly. So, here we go. If I am multiplying bases, you add your exponent, so what is 1 plus 3? 4, so that's fourth root of 4 to the fourth. That's an equals, not a times sign right there. Sorry. So lo and behold, those guys cancel out, and you're left with a 4. Cool. All right, let's deal with the top. Both of those are to the fourth power, or to the fourth root, right? So I can write it as the fourth root of 19 times 4 cubed. All right. Multiply that out. What do you get? I think it's like 768 or 86 or something like that. I'll pause this. 1268? 1216? All right. All right, so you've already gotten the rationalize on the bottom. Okay, so cleaning it up from here is kind of like cleaning your garage or cleaning that one closet that nobody wants to touch. All right, everything goes to hell for a few minutes first. It looks horrible, but then it slowly gets better. You follow me? Because 1216 does not look like a fun one. So we'll just start dividing it by perfect what? Squareds, perfect thirds, perfect fourths, perfect fifths. Fourths. Why? Because it's a fourth root. So let's just try something. Do 4 to the fourth would work. Try that one. If that doesn't work, try 3 to the fourth. I don't think it's 5 to the fourth. And figure out which one gives you a whole number. Yep. It's 2 to the fourth, actually. So 2 to the fourth times 76. So here we go. Let's rewrite that. We now have the fourth root of 2 to the fourth times 76 divided by 4. Okay? Because when I divided 1216 by 2 to the fourth, I got 76 as an answer. Okay? So, all right. Can I pull one of those two numbers out of the radical? Which one? The 2. The 2 has the fourth, so it can come out, and the 76 stays behind. All right. Do you see anything else you can do? Reduce it. Okay, 2 fourths. Reduce it down to what? 1/2. So the fourth root of 76 over 4. 2. Thank you. Thank you. Cool. So that is your entire problem in its entirety. Now, really the goal was to get, come on, piece of monkey poo, was to get this bottom part done. All right? But in the process of doing that, we created this, which needed to be reduced. All right? And while that may look crazier than the original, it really is easier to use in the long run. Okay? It's one of those to where it looks crazy, but it is easier to use than the other one. All right, turn the page. I'm going to skip letter E. I want to go to letter F. Question. Is the 4 under a radical? So do I need to rationalize the denominator there? Yes. That is actually the 5th root of 3 divided by the 5th root of 4. Okay? So how many more 4s do you need down there? 4. I got 1. To make it 5, I need 4 more. Okay? So multiply it by something and then reduce it. Get yourself all the way down to 4. Get to that point. Okay? Take, I don't know, 20 seconds. All right, did you get yourself all the way to the 4 on bottom?
Yes.
Good. All right, so since we did 5th root of 4 to the 4th on bottom, what do we got to do on top? Multiply by the same thing. And 4 to the 4th. All right? Multiply out the top. Don't reduce the radical yet. Just go ahead and get down to that really big number over here. And see if we get to the same thing. Okay? Oh, that's where that number came into play. Did you get 768 on top?
Yes.
Cool. All right, where are you going to go from here? Divide by what? Reduce it. Jonathan, how would you reduce it? Okay, what would I be dividing this thing by?
2. 2, 5.
Something to the 5th power.
2 to.
So 4 to the 5th. Okay, I don't know if that one worked. You may have tried that one first, then you probably tried this one. 2 to the 5th times what? 24?
Yes.
Okay, so if that's the case, what number would go in front of the radical right here, the 2 or the 24? The 2, good. What number stays under the radical? The 24. I got a 4 on bottom. And the last thing you do is divide. 2 fourths is 1/2. And this is just one of those things that you're going to have to do a couple of times until you kind of get used to it. Okay? It's kind of just building stamina is all it is. But there's really no trick to it. There's no hidden things to look out for. It is the same thing every single time. All right? There's no tricks. It's just brute throwing algebra at it. All right? And this is probably the hardest thing in the first two sections of chapter 6. Straight up. It's going to get easier from here on out in this section. Okay? But any questions on letter F? Anything about what I got anywhere? Yes?
So on the first line with the 5, 3.
Okay.
Why?
Go for it.
Guys?
I don't care if you come up here. That's fine.
So, 4. I think it's going into this one. Why is it 3 enough?
So you're asking why from here to there. From there to there.
Yeah.
All right. It goes back to, we talked about it a little bit last class.
No, why from there to there? Why is the change to a 4?
Why does it change to a 4? Okay, so this is the original problem. Okay? And we're multiplying the entire fraction by that entire fraction. So since these are the same radical, both radical 5, I can rewrite that as radical 5 3 times 4 to the 4th. I can bring those together into one radical,
Okay.
which got me that one. Does that make sense?
Yeah.
That's what happened there. That's an excellent question. Anything else? All right, cool. Let's keep rolling. Problem 4. Write the radical in simplest form. Okay, so this one's a little bit different because we no longer have just a radical. It's a radical plus or minus something down there. Okay? So let me give you a little bit of something. If I were to factor this, let's say x squared minus 9. Do you remember how to factor that? X minus 3 and x plus 3. Okay, those are conjugates of each other. Remember, they're the same thing, but one's got a plus and one's got a minus. And the nice thing about conjugates is there is a 0 for a middle term. There is no middle term. Okay? That is very useful when you're trying to get rid of a radical or you're trying to get rid of an I. Okay? We want to multiply it by something that would get rid of the middle term. So we are going to multiply it by its conjugate. So here we go. That x squared minus 9, I just made that up to use it as a side thing. That's all. It's not part of the problem. I just trying to show you where we're going with this. All right, so here we go. I've got, instead of 5 plus root 3, I'm going to do 5 minus root 3. And whatever you do on bottom, you got to do on top. Cool? And just so you believe what I'm doing here, I'm not trying to do some hocus pocus over you or anything like that. Don't write this down, just follow me. So if I do 5 plus root 3, 5 minus root 3, and multiply that out, what is root 3 times root 3? Not 9. It would just be 3. Square root of 3 times the square root of 3 is 3. Okay? Negative root 3 times 5 would be negative 5 root 3, because I can't really merge them. If I do this one, 5 times root 3, that's a positive 5 root 3. And then a 5 times 5 is 25. So the key to look for, those two cancel each other out, don't they? Yes, those add up to 0. That, and are there any root 3's left? Just a 25 and a negative 3. That is why we did this. So only in this case, only when you're dealing with conjugates can you ignore this and just multiply the front and the back. Okay? So just do this. 5 times 5 is? 25. Root 3 times root 3 is?
Root 3.
Not root 3, but just 3. And it's negative because it's a positive times a negative. And then 1 times anything is, well, just itself. So 5 minus root 3 on top. Cool? There's one more thing you can do with this. What's 25 minus 3? 22. Equals 5 minus root 3 over 22. And that would be your answer. Cool? These are a lot simpler. All right, let's slide over to the next one. Slide over to letter B. So here we go. Let's do this one. To get rid of that denominator, multiply it by what?
2.
Square root of 7 plus 2. Very good. And whatever you do on bottom, you got to do on top. So multiply the front. What's root 7 times root 7?
7.
7. What is negative 2 times positive 2?
Negative 4.
Negative 4. Cool. All right. Multiply the top. What's 6 times root 7? You just got to put them next to each other. And 6 times 2 is?
12.
12. Don't worry, Jonathan. Somebody's done that every single period. Like 42 or this or that, or it's 5.2793. Yeah, whatever. It's okay. There's actually 2 more things we can do to this. What is 7 minus 4? Let's combine that. 3. Yes. Now, it's one of those all or nothing type deals. All right? It's either I divide both of these by, all 3 of these by something, but I can't just do these 2 or just those 2. Because there's a plus, it's all or nothing. But I can divide them all by 3, right? So 6 divided by 3 is? So 2 root 7. 12 divided by 3 is? So 4. 3 divided by 3 is? 1, but do I have to put over 1? No, so don't. That's your final answer. And this is one of the times that the answer really is prettier looking than the original. Cool? So rationalizing these denominators are considerably easier. How are we doing with all this? Give me 5 to 1. 5, I got this. 4, I'm okay. 3 and 2, I'm lost. 1, save me. I know it's Friday. You'll make it. I promise you'll make it. All right. All right, this is getting even easier. You ready? Letter A. Are those the same?
Yeah.
What's 7 plus 1?
8.
Done.
Give me that.
They are identical roots. So just like if it was x squared plus 7x squared, that would be 8x squared. It is identical. It's 8 times the 4th root of 10. Okay? Letter B, same idea. Are these identical roots?
Yes.
Yes, so what's 10 plus 2? So 12 times 8 to the 1/5. And if you put the 1/5 inside versus outside the parenthesis, it doesn't matter. It's still 8 to the power of 1/5. Cool? I'm just using it as a separator between the 12 and the 8. Cool? Told you this was easier. Henry, you had a question.
About problem 8.
Okay, what about it?
Why you put 9?
It's not a 9, it's a 4. I know, it looked like a 9. I know it did. It is a 4. All right, letter C. Can I combine those two?
No.
No. But can I reduce the 54?
Yeah.
Okay, so we're going to divide these by what? Perfect squares, perfect thirds, perfect fourths, perfect thirds. Okay, so try 4 to the 3rd. If that doesn't work, try 3 to the 3rd. Well, 3 to the 3rd is 27. Yeah, it's 3 to the 3rd times 2, which you notice how both of those have a 2 in them? They were built in order to pull them together. So that would be the 3rd root of, which number goes on the outside, the 3 or the 2? The 3. The 2 goes on the inside, minus the 3rd root of 2. Which is what? Three minus 1 is
Just 3.
2.
Because that is a 1 right there.
It is not written, but it is there. Cool. How are we doing this? Give me 5 to 1. 5, I got this. 4, I'm okay. 3 and 2, I'm lost. 1, save me. All right, do the next 2. Do D and E. Do D and E real fast. No. Why? You hungry? He's like,
Why you leave it inside and letter E?
oh, the exponent?
Yes.
I could write it like that. I could write it like this. Heck, I could even write it like this. The third root of 9 squared. They all mean the same thing. You follow me? Just different ways of writing it. All right, any questions on D and E? All right, F. Are those the same?
No.
All right, which one are you going to reduce, the 5 or the 40?
40.
All right, knock it out. Don't yell it out, knock it out.
No.
I got it right away.
Take the roof off the sucker, take the roof off the sucker. Yeah, take the roof off the sucker. Any questions on how I got anything up there? Right back there? Okay.
Wait. Give me a second.
Are you cool with why I did this?
Yeah.
All right. So I took this and I built that.
Wait.
Does that make sense? Because I could take the third root of 2 and put the 2 out front. The 5 stayed behind. Cool. I think we're just going fast is what it is. Then I add my coefficients. 2 plus 1 is 3. Cool. All right, any questions on this page at all? Anything you want to talk about? All right, next one gets a little bit easier.
He's here.
First things first, anybody know the third root of 64? Do you remember?
8.
5.
4. 4 times 4 times 4 is 16, so that is 4 on the outside. You can already take care of that part. Now, the variables. Variables are like this. All right, that's a y to the 6th. So I got 1, 2, 3, 4, 5, 6. How many groups of 3 can I pull out of that? 2. 1, 2. Are there any left over?
No.
No, so I have a y squared outside. There are 6 in there. How many groups of 3? 2. If there were any remainders, the remainder would be left underneath the radical.
Mr. Hunter, how do we get the number 4?
What is the third root of 64?
4.
4. That's where it is. All right, letter B. Same idea. Your x. Okay, so this time we're looking for groups of what? 6. How many groups of 6 are there for x? 1. So it's just x to the 1. How many groups of 6 for the y's? 2. So y what? Squared. Dun, 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 done.
So the number on the outside of the root is basically the number of groups?
That's how many groups. Which honestly, this over here, the 64, is a group of 3 4s. Does that make sense? So it is the same thing, it's just written a little differently. All right, try C and D. Do C and D real fast.
Oh, Lord.
Try right there. You okay? Oh.
That's what I was saying.
Did you figure it out, or was it just something dumb?
Something done.
Okay, I'm sorry. All right, any questions on this at all?
No.
Okay. 7 gets a little bit harder, but not by a whole heck of a lot. Okay? Can you take the 5th root of 4? No. It's so small, I can barely take the square root of 4, let alone the 5th root of it. So that's got to stay behind. But how many groups of 5 can I take out of that one? 1. So here's what I'm going to do. I'm going to write my A to the 1 out front. I'm going to write myself a little note up here because how many, oh, not a 5. How many are left behind? 3. So I'm going to write a little note of a 3 up there just so I know about that. For the B, how many groups of 5 can I take out of the B?
2.
So it's a B squared. How many are left behind? 4. How about the C? 1. How many are left behind? None. Okay, so that's what comes out, and what gets left behind is 4a cubed b to the 4th. So that b's a little funky, but that's what it is. So if they don't come out nice and pretty, that's what happens. And if the 4 could have reduced, let's say it was 64 in there, I can break a 64 into a 2 to the 5th, which is 32, and a 2. So 1 2 would come outside the radical, and the other 2 would stay in. So if you can break up the number, do it as well.
The A, B, C, you don't count it like, or you just put them in order.
Okay, here's what happened. I say, oh, there is 1 group of 5 in there. So that's where that one came from. There,
Yeah.
with 3 left over.
Yeah, I get that. But I mean, you have to put it in the answer.
That is the answer. That whole thing is the answer. The parts out front is. All right, try letter D. Go do letter D real fast. D is just like it. All right.
So 4 you cannot take it, right? So 48. Can you take the 4 of 48?
Well, try dividing it by 3 to the 4th, or try dividing it by 2 to the 4th, and see what you get.
No. Straight, yeah, I have it.
Cool. So if you got the variables, I'm happy at the moment. Does that make sense? If you didn't get the 2 and the 3, I'm okay with it at the moment, but it just kind of mixes the 2 together.
So
You need to get to where you can. Does that make sense?
I think I understand this part.
So